Hi, my name is Peter Schoenmaker. I'm going to talk about the higher speed study group that was started in the IEEE group. Basically, the IEEE formed a new study group to look at developing a standard for Ethernet that uses a speed greater than 10 gigabits per second. In July of 2006 of this year in San Diego, there was a call for interest, which is a presentation or a request to the IEEE 802.3 group to decide if that people want to pursue looking at developing the standard for a higher speed Ethernet. The study group was approved. It required a 50% vote, and basically they had 53 yes votes, 3 no votes, and 3 abstains. So there's an overwhelming interest in forming the study group to look at new speeds. Each study group actually has a 6-month lifetime, so there's some time schedules and deadlines that they actually have to meet in order to make it out of the study group. Otherwise it expires, and a new call for interest must be introduced to look at the same topic. You can get a 6-month extension to extend that beyond the original 6 months so that you can finish the work and get out of the study group. In September, there was the first actual HSSG working group or study group meeting in Knoxville, Tennessee, and the next one is November. There's a 802 plenary in Dallas, Texas, where they'll meet again. So the study group is basically just looking at the criteria or the desire to build the standard. So there's a couple of things that you have to do to actually get out of the study group. And the first thing they have to do is design the objectives. So the objectives are just the design criteria for the new standard, what they want it to do, how they want it to work, any constraints basically on the design. After that, the HSSG study group is actually different in the past because old study groups always came out with only one what's called PAR and 5 criteria. Basically, they were only going to develop one standard. But because of looking at the breadth of previous study groups and the number of standards that actually came out of the 10 gigabit, there may be a potential for having multiple task force or standards working groups come out of this study group. So once the objectives are actually defined, the study group will evaluate the objectives and the number of projects within those objectives. And then they have to generate what's called the project authorization request. So the project authorization request is just a summary of the work, what they plan on doing, scope, that sort of thing. And then there's also the 5 criteria, which defines the feasibility or the popularity of the actual standard. So you can actually look at the 10 gigabit Ethernet study group, which is a really good example for looking at the process and what they've done for that. I've listed the URL, and the best thing to look at is the 10 gigabit per second Ethernet tutorial. So they have the 5 critters here, and these are basically the 5 criteria that must be met in order for the study group to be accepted. So the 802.3 working group actually votes on 2 things: the PAR, which I talked about earlier, and the 5 criteria to decide if a task force should be formed to actually define the standard. So the first criteria is broad market potential. You have to define and determine how many people are actually going to buy this product, how many ports they're going to buy. And this is actually one of the big problems they're facing in the HSSG working group, which really affects the network operators, because a lot of the people are looking at the very high volumes of ports, and when they're trying to get a better grasp on actually how many people will actually buy a port speed that's higher than 10 gigabits per second. We know there are some people out there that really need it, but the question is how many people need it and how many ports do they really need? Also, because this working group is in the 802.3 Ethernet group, the compatibility, so it has to actually be compatible with the previous standards. And then it also has to have a distinct identity. So the distinct identity basically means that it has to be different from every other standard. And the higher speed Ethernet is pretty easy to meet that criteria just because it's faster. So it gives it a distinct identity. And then technical feasibility. Can we actually build the standard, build product, deliver product that's based off the standard that's defined? And then they have the parakeet, which is cheap, cheap, cheap. So for economic feasibility.
That's really bad.
So it has to be actually, people have to be able to afford this, and they actually have to make it at the price that that meets the marketplace. So those are the 5 criteria. And the compatibility and distinct identity are relatively easy. It's the other 3 that are really the more difficult bar to meet. So to build the PAR and the 5 criteria, we first define the objectives. So the objectives are just kind of the constraints of the design. So I put up some examples of the 10 gigabit per second constraints, and one of them is the goal is to preserve the 802.3 Ethernet frame format, support full duplex operations only, because the study group decided that you don't need half duplex in this day and age. And then they also defined 2 families of PHY, so the LAN PHY and the WAN PHY. There's about, I think, 10 or 15 other ones that you can see in the tutorial, but those are just kind of examples of what the higher speed study group will define. So in the first meeting, there's a lot of discussion kind of about the direction and kind of how they want to attack the actual standard. So one of the main debates is that speed. For a lot of people, I think they assume that it's going to be 10 gigabits per second, but there's a lot of debate about actually what the true speed is going to be, because people are looking at multi-lane approaches, so they're looking at how many lanes, so they might have 4 lanes by 25 or 10 lanes by 10. Some people are looking at serial, so it could just be a fixed rate, and other people are also looking at the scalable speed, so it might actually be able to go from 20 gigs to 200 gigs or higher. And people have basically proposed anywhere from scalable speeds to 80 gigabits per second, 100 gigabits per second, 120, even faster. Traditionally, the tradition is in 802.3 is to go 10x the speed, so we've gone 10, 100, 1 gig, 10 gig. But there's some concern that we might not be able to go that big a jump and follow the tradition in the 802.3 group that you get 10x the speed for 3 times the cost. The optics are pretty scary for the 10 gigabit per second rates, or even 80 gigs. And then also some people have talked about proposing the Sonnet SDH compatible speeds, just so that there's a belief that there might be a better compatibility with existing DWDM and layer 1 infrastructure. The other big debate, there's 2 more, and the distance is the second big one. And there's a lot of people are really worried about how long does this actually need to go, where's the market potential, how far are most of the ports going to need to be used. Different speeds have been talked about for different marketplaces too. So there's talk about the less than 10 meters, and the less than 10 meters is basically for backplane uses within a router or chassis. 100 meter is short distances, and 300 meters is kind of data centers. 2 meter can be data center, and then it overlaps with some metro, and then it goes up to 10 kilometers and 40 kilometers and even higher. And the last real big debate now is the fiber optics discussion. So the multi-mode fiber, some people want to do multi-mode fiber, whether that's needed or not. Single-mode fiber is also been considered. But the more interesting conversations is a lot of people are looking at some VCSEL support, DWDM within the serial, within the single-mode fiber, or even serial. There's also been concerns about, or talks about, ribbon cable, and even just having multiple ports with multiple fibers plugged in. So one of the important things is that the objectives haven't been defined yet. So there's a big need for the operators to have influence about what they need, whether a lot of the discussions are fit with the infrastructure that they have today and fits the needs that they have in the future. You can find out more information by visiting the HSSG working group or study group website, or you can contact also the study group chair, which is John D'Ambrosi. That's all I have. Thank you.